Bismillah ar-Rahman ar-Rahim. Welcome to Lady Khadija radiallahu anha online college live lesson, A-level maths year 2, pure maths, working through the Edexcel Pearson UK A-level syllabus. This is chapter 3, geometric sequences, carrying on from the last few lessons. This time looking at the sum to infinity. If you're working through the book, then this is example 15. Okay, let's just remind you what a geometric sequence looks like. You've got a number, which then to get the next number in the sequence, you're going to multiply that number by something. In this case, I'm going to say the sequence doubles each time, so the multiplier is times by 2. And then we have a is the first number in the sequence. That's your a. And we have the multiplier from one number to another is the ratio, so we call that times by r. And that's the basics. And then that's the basics of the geometric sequence. This time we're going to take a sequence, and if we say we're dealing with fractions, so we've got 1, 0.5, and then 0.25, and then 0.125. With this type of sequence, because we're multiplying by a ratio which is less than 1, so in this case we're multiplying by 1, by a half, 1 over 2. Then what happens is that the numbers get smaller and smaller as you go along. So it's possible to keep adding this sum and find out what would it add up to if we went on forever. That's called the sum to infinity. And the formula to work out that is very, very easy. It's a over 1 minus r. So remember that a is the first number in the sequence, and r is the multiplier between one number to the next number. So in this case, we would do 1 as your a, and then your r is 0.5, so 1 minus 0.5. Unlikely that you're going to get a question that easy, so let's take a look at this example, which is example 15 in the book. So this will give you a bit more of a level of where you need to get to. So the fourth term in a geometric series is equal to 1.08. The seventh term is equal to 0.23328. And the question is, can we work out the sum to infinity? And before that, can we show that the sequence is convergent? So part A, show that it's convergent, and part B, work out the sum to infinity. Convergent just means that the ratio is less than 1, so that the numbers are going to get smaller and smaller. So let's work out the ratio first, because we're going to need that anyway to get the sum to infinity. So the general form for the nth term, if you remember, the general formula is a times r to the power n minus 1. That will tell you the general formula for any number in the sequence. We're looking at the fourth term, so we know that n would be 4. We don't know what a is, and we don't know what r is. So all we can say is that a times r to the power of 3, because 4 take away 1, would be equal to 1.08. Then from the next line, we can say, take the same formula, a unknown, r is unknown, n is a seventh term, so 7 take away 1 is 6. So we can say ar to the power 6 this time would be equal to 0.2328. Now you've seen this kind of situation before, so if you can type into the chat box what I should do next, if you remember. Okay, I'm going to take the smaller power equation and put it underneath. And then what I'm going to do is divide one equation by the other. So the a's on the left-hand side will cancel out. And r to the power 6 divided by r to the power 3 is just going to become r to the power 3. And then using a calculator, I just need to divide 0.23328 by 1.08. So if you can do that as well, just to make sure that you know how to do this, 0.23328 divided by 1.08, and that gives me 0.216. And then if I cube root that, I should get 0.06. Sorry, 0.6. Let me just check that. Yep, that's fine. Let me just double check that again. Yep, 0.6. So there's your ratio, there's your multiplier, and we can say that it is convergent because the ratio is less than 1. So we would say because r, the modulus of r, the absolute value of r is less than 1, therefore it's convergent. Now let's use that new formula for today, which is the sum to infinity is equal to a, can you remember the last bit, over 1 minus r. Well done if you remembered that. So it shouldn't be too hard. We just need to figure out what a is. So 0.6 is your r. If we plug that in to, looks like this might be the easier one to go for. So I'd have a times 0.6 cubed is equal to 1.08. And then if you solve that by taking the 0.6 cubed to the other side, then you just need to type that into your calculator. 1.08 divided by 0.6 cubed, and that's 5. So the first term is 5. So we're ready to use the sum to infinite formula. We know that a now is 5. R stays the same as 0.6. So if you just want to type that into your calculator and see what that gets you. 12.5. And just in case you see it in the exam and you're a bit confused, the sum to infinity can be written as this, S, big S, and then the infinite sign. Okay, well done. Sum to infinity is 12.5, and that's geometric sequences, sum to infinity. For more work on this chapter, join me again tomorrow. Assalamu alaikum wa rahmatullah. Peace be with you and the mercy and blessings of God.